Imagine a strategy that looks steady until losses arrive in clusters. A simple shuffle can spread bad days apart and make the path gentler than the market rhythm that created it. The question is not, can we invent a prettier history? It is this: if recognizable return runs stay together while rearranged, can the path expose fragility? A Monte Carlo block Bootstrap tries to stress that. Financial returns are rarely independent coin flips. Trends, volatility bursts, and liquidity shocks can make neighboring days resemble each other. Independent, identically distributed resampling lifts one return at a time and breaks those neighbors apart. A block Bootstrap keeps short stretches intact. Drawdown changes when order changes. Path sharp changes here because blocks sampled with replacement can repeat some returns and omit others, changing the sample itself, not because mean divided by standard deviation is order sensitive. Here is the exact stationary circular recipe. Start with a clean return tape of length t. Draw a start position uniformly from the tape. Draw a block length from a geometric distribution. The configured mean is 4 observations. Copy that contiguous block. At the tape's end, wrap to the first return. Draw another start and length, stitching blocks until the synthetic tape is exactly t observations long. This differs from the series' trade order permutation lesson. That route reorders every realized trade exactly once. Without replacement, its trades and sum stay fixed. This route resamples blocks with replacement. A return may appear more than once in one synthetic path, while another may not appear. It tests clustered return paths, not only fortunate trade order. Use this 12 return tape only as a teaching example. Plus 0.6, plus 0.3, minus 0.2, minus 1.0, minus 0.7, plus 0.1, plus 0.5, plus 0.6, minus 0.3, and plus 0.2%. Its uncompounded sum is plus 0.1 percentage points. Draw blocks 4-3, 8-4, and 12-5. The last wraps after return 12. We changed both order and frequency while drawing only from the source tape. Block 4-3 gives minus 1.0, minus 0.7, plus 0.1. Block 8-4 gives plus 0.8, plus 0.4, minus 0.6, minus 0.3. Block 12-5 gives plus 0.2, then wraps to plus 0.6, plus 0.3, minus 0.2, minus the stitched 12 observation tape sums, uncompounded, to minus 1.4 percentage points. It is illustrative arithmetic, not a market sample, strategy result, or forecast. The current route receives dense weekday dollar P&L. Same-day net P&L is summed, and a flat weekday is $0. That ordered series is the real input. The percentage tape you just saw is a separate mechanics toy. Fewer than 24 usable observations is a refusal. Otherwise, the route draws 100 same-length paths with mean block length 4 and seed 42, computes a sharp for each, and counts the fraction below 0. Regime tags are only length-checked, not used to form paths. This is veto-only stress, not a promotion engine. Here is a second toy. Suppose 23 of 100 paths have negative sharp, 0.23. The configured veto line is 0.2, so this toy would fail it. Show 23 adverse paths on a 0 to 100 count scale, with the 20% line beside them. It reports no actual run, it only explains the route's comparison. Block length is a modeling choice, not a dial to turn until the answer looks safe. A block of 1 approaches independent resampling. An extremely long block creates few rearrangements. Mean 4 states the present setting, not what every market requires. A credible sensitivity study declares several reasonable block lengths before results, then asks whether the inference changes. This implementation measures none of that sensitivity. It also produces no drawdown tail estimates or confidence intervals. Misuse begins when someone tunes block length after a failure, then calls the survivor robust. It also begins when synthetic paths are called independent market histories. They are rearrangements conditional on one observed tape. Resampling strategy returns does not replay the search that selected the strategy. Selection bias, revised costs, Execution, capacity, and unseen structural breaks need their own evidence. If a configured test passes, it says only this: under the chosen 100 path, mean 4, seeded block resampling stress, the negative sharp fraction stayed at or below its configured veto. That is a bounded signal about one form of path fragility. It does not prove future profit, correct logic, stable parameters, live execution, or universal robustness. It clears neither a trading decision nor the need for independent evidence. The practical habit is simple: freeze the strategy and stress settings, preserve local runs, inspect the reported negative sharp fraction, and treat the threshold as a stop sign, not a finish line. The path-by-path sharp view we used was an illustrative teaching aid, not a public output of this route. Then measure the missing evidence separately: drawdown tails, confidence intervals, regime conditioning, and block length sensitivity. This implementation does not produce them. Randomized paths challenge your story. They do not grant trust.